In this tutorial, we'll explore Rive's new converter scripts and how they add a logic layer between the data in the view model and your animation, with the help of the Rive AI agent. We'll build a sun and moon system that reacts to time, where both elements move dynamically based on the current hour, sunrise, and sunset, all controlled by a single custom converter script. So let's get started. First, let's take a quick look at the file structure and the components we're using for this tutorial. The first is a sun component, which includes a simple glow animation when we play it. We also have a moon component, which includes a similar, simple glow animation. There's also a clouds component, which contains a basic idle animation of clouds moving across the background. And finally, we have the main artboard, where we'll build the layout and connect it to the converter script logic. Let's start by adding the sun and moon elements to this main artboard. We'll use the component tool to add the sun artboard and position it high up in the center of the canvas. Next, we'll add the moon artboard. We'll align it directly beneath the sun, outside the artboard boundaries, so both elements can rotate around a single center point and create a circular sun and moon motion. Now we'll select both components, group them together, and name the group Sun-Moon Orbit. It's important to make sure the group's origin point is vertically centered and aligned to the bottom of the artboard, so when we rotate the group, we get a clean, circular motion. If needed, you can press Y on the keyboard to move the origin and align it to the bottom. Now, looking at the rotation property, we can see that at 0 degrees the sun is positioned at the top of the sky. At 90 degrees the sun is setting and the moon begins to rise. At 180 degrees the moon is positioned at the top of the sky. Notice that because of the rotation, the moon is currently flipped. The shading is on the wrong side. Let's select it and fix that. We'll flip its orientation by adjusting the axis using negative values. Now, when it's positioned at the top of the sky, it's facing the correct direction. Let's play with the rotation value. As we rotate the group, you can see that both the sun and the moon rotate around the same point, creating the illusion that they're moving based on time. Now that we set this up, let's reset the rotation back to 0. What we're seeing here is a single angle controlling the entire system, the sun at the top, the moon at the top, and everything in between. Perfect. Eventually, we want this angle to be driven by 3 properties: the current time, the sunrise time, and the sunset time, and use a converter script to turn them into a single, computed angle. But let's take this step by step. The first thing we'll do is connect this angle to data coming from the view model. Let's open the data panel. There's already a default view model here, so let's add a new number property and name it angle. Now we'll connect the group's rotation to the angle property. We'll select the group, go to Rotation in the Properties panel, and bind it to the angle property. Notice that Rive automatically adds a converter called degrees to radians. That's because rotation doesn't work directly with simple numbers under the hood. Rive handles the conversion for us, so we don't have to worry about it. We'll keep this converter in place so we can bind simple degree values and have them automatically translated into rotation. Now let's run the state machine and make sure everything works as expected. Right now, the angle is set to 0 degrees. If we set the angle to 90 degrees, the group rotates accordingly. And at 180 degrees, the moon appears at the top of the sky. If we use -90 or 270 degrees, we complete the full circle and the sun starts rising again. Let's enable clipping for a moment so we only see the elements inside the artboard. Now, as we adjust the angle, the motion feels much more natural, and it really looks like the sun and moon rising and setting. Let's disable clipping for now so it's easier to continue working. Up until this point, we've been working with a direct connection between values and rotation. The next step is adding logic that evaluates the time of day and converts it into an angle. And that's exactly what converter scripts are designed for. A converter script allows us to take incoming values, apply logic and transformations to them, and return a new computed value in their place. For example, in this case, we want to know whether the current time is before or after sunset, so we can decide whether to show the sun in the sky or switch to the moon. So let's get started. First, we'll create a simple converter script, make sure it works, and then gradually build the more complex logic on top of it. So let's create a new script. Go to the toolbar, and under Scripts, choose Converter Script, since we want a script that transforms data. You can see it opens in a new tab with a default script. Let's switch to Split View so we can see both the canvas and the script side by side. Now let's walk through the script and break down what each part of the code is responsible for. As you can see, a default converter script has been generated with the default name Converter Script 1. At the top, we have a section called My Converter. This is where we define all the inputs our script can work with. In this tutorial, those inputs will represent the current time, the sunrise time, and the sunset time. We'll set those up shortly. Underneath that, we have Data Input, which defines the type of value the converter receives. It's currently set to number, and since we're working with an angle, we'll keep it that way. There's also Data Output, which defines the type of value the converter returns. Again, since we want the converter to return an angle based on the time of day, we'll keep this as a number. And now we get to the function that really matters, convert. This function is where our logic will live. It's where we'll either write the logic ourselves or later let the Rive AI agent generate it for us, handling the transformation of our data, for example, converting the time of day into an angle. Let's briefly look at the code. You don't need to understand every detail here because we'll be using the Rive AI agent to generate the actual logic for us. You can see in the comment here that this default converter simply adds 1 to the incoming value. So if our angle is 90 degrees, the value returned by the converter would be 91. Let's change that so we can clearly see the script in action. Instead of adding 1, we'll multiply the value by 2, using the asterisk operator for multiplication. Great! Now, any value we pass in will come back multiplied by 2. At this point, it's important to save the script. You can see this indicator showing that it hasn't been saved yet. Let's save it using Command S. The script will now appear in the Assets panel. Now we want to create a converter from this script. To do that, click the Generate Converter from Script button. You can see that we've switched to the Data panel, and a new converter called MyConverter1 has been created. Let's rename it to Convert Time to Angle. Great. Now we want to make sure this converter actually works. To do that, we'll connect it to the Angle property. So let's go back to our main artboard and select the Sun-Moon orbit group. You can see that we already have a binding on the Angle property we set up earlier. Let's update that binding. Notice that we already have a degrees to radians converter here. That means we already have one converter in place that we want to keep, while adding our new converter. To do that, we'll create a converter group. A converter group allows us to chain multiple converters together and apply them to the same property. So let's go back to the Data panel. We'll click the plus icon, add a converter, and choose Converter Group. Let's rename it Converter Group Convert Time to Angle. Great. Now we have a converter group, and we want to add the two converters we already have into it, the degrees to radians converter and the Convert Time to Angle script we just created. Let's move it up in the list to keep things organized. Now, with the converter group selected, we can add the two converters we've created from the Properties panel. Let's click the plus icon, choose to add an existing converter, and select Convert Time to Angle. This is our script. We'll also add degrees to radians. So now, the converter group first uses the Convert Time to Angle script to modify our angle, and then passes the result into the second converter, which turns that value into radians, the unit the rotation system actually works with. The order here is very important. First, we modify the value with our script, and only then we convert the result to radians. You might notice a warning here, but there's nothing to worry about. Everything will still work. This is just a minor Rive editor issue. Great. Now that we've created the converter group, all that's left is to update our data binding. We'll select the group, right-click the rotation property, and choose Update Binding. Now, under Convert, instead of just degrees to radians, you can see the Convert Time to Angle script we created, as well as the Converter Group Time to Angle, which contains both converters. Let's choose this one. Perfect. Now, this converter actually contains two steps. First, it uses our script to take the angle and modify it, in this case, multiplying it by 2. Then, it converts the result from a number into radians. In other words, if we run the state machine and set the value to 45 degrees, we'd expect the sun and the moon to rotate by 90 degrees. Let's set the value to 45. And as you can see, both elements rotate exactly as expected. That's because we took this number, which is the converter's input, and multiplied it by 2 inside the convert function. Now, this isn't really the logic we want yet, but it does confirm that our script is properly connected and working with the converter. Before we continue, there's one more function worth briefly mentioning. So far, we've been working with the convert function. There's also another function called reverse convert, which does exactly the opposite. In our case, we updated a value in the ViewModel, and Rive used the convert function to update what we see on screen. What reverse convert defines is the opposite scenario. When a value changes on the screen, how that value should be written back into the ViewModel. In this example, this function isn't relevant, but it's important to be aware of it, since it can be useful in other scenarios later on. Now we're ready to add the actual logic that will control how the sun and the moon move based on the time of day. To do that, the first step is updating our ViewModel. We'll add 3 properties to drive the animation: the current hour, the sunrise hour, and the sunset hour. So let's add a number property and name it current hour. Next, we'll add the sunrise and sunset times. We'll start by adding another property and naming it sunrise hour. Next, we'll add another number property and name it sunset hour. I'm getting a warning because of the capital letter, so let's change it to lowercase. Let's arrange these in order: current hour at the top, followed by sunrise hour, and then sunset hour. Now let's set some default values. We'll set the current hour to 12 p.m., right in the middle of the day. We'll set the sunrise hour to 5 a.m. and the sunset hour to 8 p.m. We'll use a 24-hour clock so we can clearly distinguish between morning and evening. So instead of using 8, we'll use 20, since we're working with a 24-hour clock. Great. Now we have 3 properties in our ViewModel: the current time, the sunrise time, and the sunset time. Next, we'll make our script recognize these properties, and based on the values in the ViewModel, it will know how to move the sun accordingly. So let's do that. We now want to link the properties we created in the ViewModel to our script. Up until now, the converter could only recognize a single property, the one we originally bound to it. So if we select our group, it currently only knows about the angle property. Now we want to pass additional data, specifically the time properties, into the converter. So how do we do that? At the beginning of the script, we saw a section called My Converter. This is where we can define additional data and inputs that the converter can work with. Let's start by adding the first new input, the current time. Let's walk through how to do this. We'll call this input current hour, which represents the current hour of the day. We'll add a colon and then define its type. Since this is an input value, we'll set it as an input of type number. At this point, we've configured the script so it can receive the current hour as an external input. Perfect. Now, when we try to save, you'll notice there's an error. That's because every input we define needs to be initialized with a default value. So let's do that. We'll copy the input name, scroll down to the bottom of the script to the last function, paste it there, and give it a default value. This is where all the script inputs are initialized. We can place it anywhere here. The exact position doesn't matter. Let's give it a value of 12 and add a comma at the end to keep the syntax valid. Perfect. You can see that the error is now gone. Now let's continue by defining the remaining two properties. We can simply duplicate current hour and rename it to sunrise hour. Then we'll duplicate it once more and create a third input called sunset hour. You'll notice the errors appear again. That's expected. We'll scroll down and initialize these inputs as well. So let's set sunrise hour to 5 o'clock. And we'll set sunset hour to 8 in the evening. Since we're using a 24-hour clock, we'll set it to 20. Great. Let's save the script. There's a small typo here. Let's fix that. Now you can see that all the errors are gone. At this point, we've set up the script so it can receive 3 additional properties: current hour, sunrise hour, and sunset hour. Now, if we select the script in the data panel, you can see that 3 new properties have been added. These are the inputs we can now bind to. If we refresh, you'll also see that the script is initialized with the default values we set earlier: 12, 5, and 20. But that's not enough yet. So far, we've only defined these properties locally. What we actually want is to link them to the properties we created in the ViewModel. We can do this very easily using data binding. For each input, we'll create a data bind and connect it to the corresponding property in the ViewModel. The current hour input will be bound to current hour, sunrise hour to sunrise hour, and sunset hour to sunset hour in the ViewModel. Great! Now the script is linked to the ViewModel and can access the current hour, sunrise hour, and sunset hour properties. At this point, we haven't changed any logic yet. Let's run the state machine. And you can see that nothing is affected right now. Even if we change the current hour, nothing happens. The only value that's still affecting the animation at this stage is the angle. This is where things start to get interesting. We want the angle value to be driven by these 3 properties: the current hour, the sunrise time, and the sunset time. When the current time represents midday, the angle should be 0. When we're in the middle of the night, the angle should be 180. This way, we can move the sun and the moon dynamically based on the time of day. This is the point where we'll stop writing the logic by hand and let the Rive AI agent handle the heavy lifting for us. First, you'll notice a new tab here called Agent. This opens a chat interface where we can describe what we want the script to do. So what we want to do here is instruct the agent to work with the existing script and use the 3 properties we've already defined to determine the behavior at different times of day. So this is what we're asking the script to do. We want the angle to be calculated relative to the current hour, the sunrise, and the sunset. At midday, the angle should be 0, placing the sun at the top of the sky. At midnight, the angle should be 180, placing the moon at the top. At all other times, the angle should change gradually, always relative to when the day actually starts and ends. At this point, we could write the instructions directly into the agent. Personally, I prefer to use ChatGPT so I can be more deliberate, think through the logic, add context, and prepare a clear, well-structured prompt in advance. So I'll paste that prepared prompt here, which is exactly what we just walked through together, and run it. You can see that the agent immediately starts processing the request. I've included this prompt in the video description below, in case you want to try it yourself. You can see that the agent also explains what it did. It mapped all of our values, generated the logic for us, and that's it. The script is ready. If we scroll down, we can see the new code it generated. Let's confirm the changes and save them. Perfect. Now let's run the state machine and make sure everything is working as expected. Once we press play, you can see that the sun has already shifted slightly to the left in the sky. Right now, we're at 12 p.m. The sunrise time is 5 a.m., and the sunset time is 8 p.m. As the current hour changes, we expect the sun to move across the sky. And when it reaches 8 p.m., the sunset time, the sun and the moon should be perfectly aligned. You can see that right now we're exactly at sunset. Once the current hour passes the sunset time, the moon appears in the sky and the sun disappears. That's because we're now in the middle of the night. Now let's look at the opposite case. What happens when the current time is earlier than the sunrise time? In other words, before the sun has risen. That means that when we reach 5 o'clock, the sun and the moon are aligned, and the sun is just beginning to rise. If we go earlier than 5 o'clock, you can see the moon in the sky while the sun is not visible yet. In fact, using this script, we've created smart logic that takes all three of these properties into account. Let's look at something else that's really interesting. Say we're close to 6 p.m., but sunset is still 2 hours away. What's cool is that the system adapts to those values in real time. If we move the sunset time earlier, for example to 5 p.m., you can see that the script immediately updates. Because the sunset hour changed, the system recalculates the logic, and now, for example in wintertime, you can see that the sun has already set. And that's it. Our script is working perfectly. Now let's add a bit more visual depth to the scene. We'll exit the converter script for now and focus on the visuals. What we'll do next is add our clouds layer. So let's bring in the clouds component we introduced earlier in the tutorial. We'll center it in the artboard, enable the artboard clipping, and then run the state machine. You can see something really interesting happening now. On one hand, we have an animation driven by a script and a converter, dynamically responding to the time of day. On the other hand, we're also using a standard artboard with a simple idle loop, the clouds moving across the sky. This shows that we can easily combine classic timeline-based animation with scripted, data-driven animation in the same scene. Great! From here, we can easily extend this system with many more examples and possibilities. For instance, we could add a background layer whose color changes based on the time of day. We could also add stars that appear and disappear, depending on the time, all driven by the same parameters we've already defined. So what did we learn in this tutorial? We learned how converter scripts add a logic layer between the view model and animation, and how to use them, together with the AI agent, to drive animation from real data. We built a smart solar system where a single computed angle, based on time, sunrise, and sunset, controls the entire animation. And that's it. If you enjoyed this tutorial and want more content like this, feel free to like the video and subscribe to the channel. And if you want to master Rive, from the basics all the way to advanced topics, check out my Rive Masterclass for designers, where we build a full weather app from scratch in Rive. See you in the next tutorial.